Welcome to clickmyproject.com. Now we discuss about the product, a bottom-up approach for Pancreas segmentation using cascade, superpixel and deep image patch labeling. Now we discuss the abstract for the process. The proposed work, the automated bottom-up approach for pancreas segmentation in abdominal computed tomography, that is the CT scans. The method generates a hierarchical cascade of information propagation by classifying images patches of different resolutions and cascading segments superpixels. The system consists of 4 steps that are decomposition of CT slice images into a set of disjoint boundaries preserving superpixels. Then second one is the computation of pancreas class probability maps via dense patch labeling. Then the third one is superpixels classification by pooling both intensity and probability feature of from empirical statistics in cascade random forest frameworks. Then the final fourth one is simply connectivity based post processing. The proposed method is evaluated on the dataset of 80 manually scanned CT volumes using 6-fold cross-validation. Finally, we implement the multi-atlas labeling fusion, that is the MALF approach for pancreas segmentation, as well as the morphological and active contour for the segmentation process. And the estimation parameters like the accuracy, sensitivity, specificity are also calculated by this process. Now we discuss the overall flow diagram for the process. This is the overall working flow for the process. At first, the input image is taken from the dataset. After getting the input image is taken from the dataset, the input image is undergone for the pre-processing step. In the pre-processing step, the image is resized into the aspect ratios. For example, if I want to resize the image into the 256 cross 256 means the pixels in the row wise is 256 and the pixel values in the column wise is 256. Then after the resizing process, the image is optimized into respected rows and columns. Then the pre-processed image is undergone for the segmentation process. In the segmentation process, we have to consider the two types of segmentation. The first one is the active contour and as well as the morphological. By using these two methods, we have to segment the image. After the segmentation, the liver region is segmentation and the liver region is formed as a ground truth. The ground truth is nothing but the binary image comes from the segmentation process. After getting the ground truth as an input, the estimation is followed to check the segmentation is correct or not. The segmentation is efficiently classified with the ground truth and then give the result as sensitivity, specificity and accuracy. By the estimation of the sensitivity, specificity, accuracy, we have to justify whether the segmentation is accurate or not. Now we discuss the initial running procedure for the process. At first, open the MATLAB 2013 and change the current directory. If you want to execute the file, select the mainfile.m and right click in that file and select the option run. After executing the file, the selected input is shown one by one. Now the file is automatically executed as well as the input image is shown in the figure 1. Now the contoured image is shown in the figure 2. Then in the figure 3 will be executed. Now in the iteration 1, 2, 3, 4 up to the segmentation process will be done. Now we will discuss the output one by one. In the figure 1, we can see the input image. This is the input image taken from the dataset. Now in the figure 2, the input image as well as the binarized image regarding with the threshold limit. Then the active contour applied in the binary image is shown in the figure 2. Then in the figure 3, the histograms of the input image is shown in the label format. Then in the figure 5 shows the segmentation result for the both the liver region and the tumor region. After getting the segmentation result, the analysis part will be carried out. In the analysis part, we have to take the true positive, true negative, false positive, false negative. Then as well as along with this sensitivity, specificity, then precision as well as recall will be taken. Here the values corresponds to these parameters are shown in the right side. Then along with those parameters, we have to calculate the FRR, FAR and GAR parameters in the tabulation 2. Here the corresponding values for the FRR, FAR and the GAR is calculated and shown in the table 2. In the figure 16, it will shows the values for the FRR graph for the proposed labels. Then in the figure 17, it will shows the FRR graph for the two labels. Then GAR graph also displayed. It is shown in the bar chart format is shown in figure 18. Thanks for watching this video.